So here we're going to do a few more practice problems using those conversion factors and bridge over troubled waters technique. Okay. Now on this first one, it asks us, I'm going to pull out the information as I read the problem. So what mass of aluminum oxide? So right away, I know I'm going to look for the mass. How many grams of this? Remember, grams go below and moles go on top. Okay. That's how we're doing the bridge over troubled waters. Okay, so let's go back to the question. What mass of aluminum oxide is required to make 27 grams of aluminum? So we know we need 27 grams of this aluminum. Okay. So just by their placement of here, just from reading the question, we know how to work this problem out. Because the bridge over troubled waters tells us we have to get it up to moles, and we can go moles to moles and make the bridge. Then we can come back down to grams. And remember, all of the vertical conversions are molar masses. So that's molar mass. This is a molar mass. The horizontal one is a molar ratio. Okay? So we can't go from grams to grams. Never, never, never. Remember to bridge. This is water. We can't get from one thing to the other. We have to make a bridge over the water. Now to help us out, we know we're going to need molar mass of the aluminum here, which we can look up in the periodic table. We're also going to need the molar mass of aluminum 2O3. And so to save us a little bit of time, and by now I hope that everyone is very comfortable calculating the molar masses. I've calculated those already. So we've got our conversion factor here, molar mass for the aluminum, and our conversion factor over here for the aluminum oxide. Okay, so we're going to use those. We're going to focus in on the problem itself rather than doing those types of calculations. Okay, we're going to start with the thing that they give us, 27 grams of aluminum. Let's put our little grid up here so we can keep the numerator and the denominator separated. Now, we know we've got to use the molar mass of aluminum to get up to moles. So that's our first step. So we're going to use this one up here. Grams are in the top, so where do grams have to be to cancel out? They have to be in the bottom. So our grams of aluminum come down here. The number is 26.98 goes with the grams. 26.98. The thing on the other side of the line, the 1 mole, goes over here at the other side of the line. 1 mole of aluminum. So the grams cancel out. And if we stopped it there, we would be up here with the moles of aluminum. But that's not what we want. So we have to do the molar ratio to get over to moles of aluminum oxide. So moles of aluminum is on top. Where do we need it to cancel out? Well, it has to be in the bottom. So let's go ahead and write moles of aluminum in the bottom. What we want to get to is your aluminum oxide. So we're going to write moles of aluminum 2O3. That goes in the top. And so where do we get these numbers? These numbers are the coefficients. So the aluminum, basically there's a 1. Ooh, there's a 1 in front of everything, and this gives us a good point. If you notice that all of your coefficients are 1, that's a good time to think, did I balance that? And in fact, this is not a balanced equation. So it gives us the opportunity, if we didn't catch it at the beginning, to catch it before we move on. Okay? So let's go ahead and make sure we have a balanced chemical equation. We need 2 aluminums for that. If we stick a 2 here, then we've got odd oxygens and even oxygens, which isn't going to work. So we're going to need a 2 in front of there. That's going to give us 4 aluminums. So we need a 4 in front of there. Then we have 6 oxygens, and so we're going to need a 3 in front of that one. Now, those are the lowest ratios possible, so we know we're good. So now we can use those as our molar ratios. Again, double check if you're getting all 1s for your molar ratios. You better double check to make sure that thing's balanced. Alright, so now that we know that it's balanced, now we can use them in the equation. Because remember, if it's not balanced, you're not going to get the right answer. So the coefficient of aluminum is a 4. So that's what we put down here. coefficient of the aluminum oxide is a 2. So that's what we put there. Alright. Now those units cancel out. Now if we stopped, we'd be up here at aluminum oxide. But we can't stop because we want to get to grams. So we need to use our molar mass of the aluminum oxide to get to that final answer. So let's go ahead and do that. The aluminum oxide molar mass is over here. And we've got moles in the top. So we want moles in the bottom to cancel out. So we'll put moles of our aluminum 2O3 on the bottom. And we know there's always 1. And then the thing on the other side of the line goes on the other side of the line. So 101.96 grams of aluminum 2O3. Okay. And those guys cancel out. The only units that are left are grams of aluminum oxide. Is that what we were asked for? Yes. Mass of aluminum oxide. Okay, I'm going to erase our molar mass here so that we have room to continue that over. Alright, so we said our units were going to be grams of aluminum 2O3. Let's go ahead and do this calculation. We've got 27, let's do all the tops. 27 times 1 times 2 times 101.96. Okay, that's the top. Now we're going to divide by 26.98 divided by 4 divided by 1, and we get 51.01779 on our calculator. Now, of course, we need to figure out significant figures. We had 2 significant figures here. 4, those are exact numbers, and 5. So 2 significant figures is what we want for our answer. And so 1, 2. The one over there is a 0, so we round down. So our final answer is 51 grams of aluminum 2O3. Here is our final answer. Okay. So remember, the bridge over troubled waters will take us from one thing to another thing. Now let's go ahead and do another problem with this. Here's the setup. I'm going to erase that first problem just so that we have fewer things on the board for us to look at. We can concentrate on our particular problem. Okay. So here's our new problem. It says, how many grams of CO2 and NH2, or NH3, excuse me, molia. So right there we know it asks for 2 different things. So I'm going to write down right now the fact that we are asked for the grams of this and for the grams of this. Okay? So we have 2 problems we're going to be dealing with here. And so it says how many grams of this and this are made from this much urea. So this is urea. Okay. We're going to put 0.83 grams of urea. Just like we saw before, we're going to do bridge over troubled waters, grams to moles, moles of this to moles of our product, and then we're going to come back down to grams. We're going to have to do it twice. We're going to have to do it 1 calculation to that one and 1 calculation to this one. Okay? 2 separate calculations. Now I have a couple of the formula weights down here. Urea's formula weight I worked out. Ammonia's formula weight as well, and CO2's formula weight as well. Because all these vertical ones indicate that we're going to need formula weights for them, or molecular weights, molecular masses. Alright, so let's go ahead and do this problem, and we're going to start with the number that they gave us. So I'm going to work it up here so that we can see what's going on. So let's start off with our NH3, because that's the closest one here. NH3. So we're going to do that one first. We're going to start off with the number they give us. So we had 0.83 grams of urea. I'm just going to write urea instead of that big long chemical formula. Put our little lines so we can then move on from there. Grams of urea is on the top, and we said we wanted to do molar mass. Change it to moles. So grams are on the top, grams have to be in the bottom to cancel out. So we put grams of urea down here. We look at our formula mass for our molar mass for urea, and it's 60.07 grams per mole. So the 60.07 grams goes there, and the 1 mole goes on the other side of the line, moles of urea. Okay. Now we said we were going to go from here to here. Now we have to go from here over to here. Those are molar ratios. So moles of urea is on the top. They have to be in the bottom to cancel out. And then what we're going to is we want to go to moles of ammonia. So we'll write moles of NH3 on the top. Now we're looking for coefficients. And if we didn't balance it before, let's better double check that we're balancing it now before we use those coefficients. Let's see. We've got 4 nitrogens over here. We've got, 2 nitrogens over here, 2 nitrogens over there. We've got 4 hydrogens. Plus 2 more, 4, 5, 6. We end up with 6 hydrogens there. We've got 1 carbon, 1 carbon. We've got an oxygen there and an oxygen there. That's 2 oxygens. So in fact, yes, this is actually balanced. So we're good to go. We can use those coefficients. So the coefficient of the urea is a 1. Okay, remember, if nothing's written there, it's a 1. Coefficient of the ammonia is a 2. Okay. So now we've converted grams to moles, moles to moles. Now we have one more step. We need to convert the moles of ammonia to the grams of ammonia. So we're going to use our molar mass of our ammonia. Moles of ammonia is on the top, so where does it have to be to cancel out? It has to be on the bottom. So that's how we decide which direction this goes in. Moles of NH3 is always 1 mole on formula the molar mass. And we've got 17.04 grams of NH3. Make sure all of our units are canceling out here. The only thing we didn't cancel out are grams of NH3. And so we can go ahead and type this into the calculator. 0.83 times 1 times 2 times 17.04 divided by 60.07 divided by 1 divided by 1. And we get 0.47089. We've got 2 significant figures. There's 4, exact. There's 4. So 2 significant figures is the smallest one. We need 2 significant figures here. So when we do that, it's this position and that position. So 0.47 grams of NH3. There's our answer. Now are we done? Well, no, because we still have CO2 to do. Remember, there's 2 parts to this question. So let's go ahead and do that. It's going to actually mirror the one above exactly. You're going to change urea from grams to moles. But here, when we do our molar ratio, we've got moles of urea, but this time we want to go to moles of CO2. So our coefficient here is 1, our coefficient here is 1, so we have a 1-to-1 ratio. And then we're going to do our final molar mass down here, and it's going to be of CO2 this time. So 1 mole of CO2, our molar mass we calculated was 44.01 grams of CO2. Make sure our units are canceling out. Moles CO2 cancel out, moles of urea cancel out, grams of urea cancel out. The only thing left are grams of CO2. We go ahead and do this problem. We've got 0.83 times 1 times 44.01. And then we divide it by 60.07. And divide by 1 divided by 1. 0.60809. 2 significant figures again. 1, 2. We're going to round up. 0.61 grams of CO2. Now we have both answers completed, and we have finish the problem completely.